from the actual engine were read by the Inca tool. They were sent across to the GT engine and actuate the GT engine in that sense. And the validation went successfully. I mean, they matched PV diagrams, they were matched all the other parameters, pressures, temperatures, etc. And to be honest, we were all like I would say we were 100% accurate. The results were on top of each other.
Welcome, everybody, to another edition of the GT Tech Talk podcast. Today, we have another exciting application of XiL, and I'm Divya, and my host today is Lalit, and we have Harshad and Pantelis with us today. So let's get things started. Harshad, Pantelis, do you want to introduce everybody to who you are, what's your background, and what you do here at GT?
Sure. Harshad, can I go first?
Yeah, go for it.
Okay, thank you, Divya. Thank you for hosting us today. Thank you for highlighting what we're doing here at Gamma with regards to XiL applications. So myself, I've been with Gamma since 9 years now, I think, if I'm counting correctly. It was the first job I landed after the college and after the Greek army obligation. So I'm here 9 years. My background is in internal combustion engines. My master thesis, my bachelor thesis is in internal combustion engines, especially marine engines. And that's how essentially I came across GT Power, right? Because GT Power is the prevailing tool in this area in the internal combustion engines. So I've been here since 2015, if I remember that. And I started as a co-simulation support engineer, let's say, supporting Simulink and FMI applications, mainly FMI at that point. We're going to say later what is FMI, right? And slowly, I think I've grown out of that support role to become the application lead, as we say here at GT, in all the XiL area.
Hi, my name is Harshad Pandit, and I have been in Gamma for over 6 years now. I just completed my 6 years, I guess, 10 days back. Before that, I was working in a couple of OEMs in US, and my background is in mechanical engineering. Through that background, I ended up developing models, like 1D simulation models. And in my previous job roles, I ended up developing real-time models for controls, calibration, validation, and all those applications. And that got me interested in this XiL domain. And the primary tool we were using was Simulink, but then we slowly transitioned into GT. That's how I got introduced to GT. And well, after a couple of years of using GT, I ended up working for that same tool and develop more features for the same application. So yeah, that's about me in short.
Yeah, thanks, Guy. Thanks for being here. And also, you mentioned Pantelis, you were in Greece, and Harshad, you're in Westmont, and that's like a very global team. Could you also talk a little bit about the team? I know that you guys work across different countries too.
Yeah,
Yeah,
sure.
we have presence. We have presence globally, right? Harshad is in Westmont. Myself, I am in Greece. We also have team members in Stuttgart, and I think we are expanding organically and nicely as you know the whole Gamma headcount.
Yeah, so to add on to that, it all started with Pantelis handling all the global requests from Greece. And after my addition, we kind of split those roles geographically, let's say, more than the application side. And then what Pantelis just mentioned, we started growing organically, and now we have our team has a presence in Stuttgart, Greece, of course, and Westmont here.
In two locations in Greece, actually, right? In the capital and in
Yeah,
the second largest city in Athens and
yeah.
in Thessaloniki. Oh, yeah.
Yes.
Thank God Harshad came a couple of years after I joined because XiL is as a domain, right, is growing. So that was great help.
Yeah, that was a great introduction, and thanks for joining us. So before we dive deep into the topic, can you provide a brief overview of this whole XIL simulation, what exactly it is, and what are the different terms that we hear in this application area, like MIL, SIL, HIL? Can you briefly explain or lay a background of these terms?
Harshad, you wanna go for it?
Yeah, sure. Let me start. So XIL is basically X in the loop. X can be M, that is model in the loop, where you have a 1D simulation model. You couple that with your controls algorithm. Mostly in the industry, it's developed in Simulink environment. So you co-simulate with that to, and your model is your plan model. It's your the system that you are developing. So you co-simulate with controls to validate the model or validate the controls. It goes either way. SIL is software in the loop where you have your controls algorithm developed into a code, C, like for example, a C code, and then you want to validate those controls in that format because that's how they eventually end up on your vehicle, different systems in the vehicle. So that is software in the loop. That's where you can use this plant model, again a physics based plant model, or it can be any plant model for that matter, even a 1D table, or anything that you may, different forms of it. You co-simulate with software in that sense. And when you talk about hardware in the loop, that's basically you are emulating a real hardware. You embed those software controls onto a real ECU. You connect it with real, sometimes with real hardwares. For example, you may connect a real actuator, a real a spark plug, or real fuel injector, whatever it may be. If you, because you want to not only test the software side of the things, but electrical connections or the all the different hardwares, are do they perform as expected. So in for those applications, you have a hardware in the loop application, where again the hardware system is emulating your your actual system that you're trying to develop. It can be vehicle, it can be a small system like engine, or even smaller system subsystem like uh, a battery or a basic cooling loop. So yeah, that's in short what Mill, Sill, and Hill is.
Yeah,
Pantelis, you want
just
to
to
add?
add, yeah, just to add a couple of comments, just to summarize all this information, which is absolutely correct. So essentially, when we say XIL, we mean we put the model, a model, because that's what we do here at Gamma, right? We produce simulation software. So you put a model in a loop with either another model, either some software, as Harshad explained, or with a physical component that is the hardware in the loop part, so that you can do some integration testing, some controls validation, some controls verification, certification, all these processes that, it is very costly and it is very time consuming to do with all the real parts together, and it's gonna take many years to see a new car out on the road if you do it all in the physical world. That's how you cut down all the cost and all the time, right? With reusing simulation models in that sense to move faster across the vehicle production, or essentially in any product development.
Yeah, that's nice that you summarized and touched on the product development cycle, because my next question was, could you kind of summarize what sort of applications that people use these for? And also, I know that different stages of product development, people use it for, like you mentioned, different variations of the XIL. And I believe that there would be different users with different motivations to use these simulations too. It's a pretty wide and very interesting field that you are in, and I think that's kind of different from some of the other applications we've also talked about in the podcast here. So could you expand a little bit more on that, because I think that's very interesting.
Yeah. So essentially, well, I think you're referring to how we identify what are our users in the XiL domain. So
exactly.
What are our XiL personas? So essentially, yes, you are correct. The users that we try to serve, they are different than the typical simulation engineer that tries to do some optimization or some performance analysis on some specific component on a vehicle or on a system that they are trying to develop at the end of the day. So just because our mission here is to expand the life of GT models, right? So you create your GT model, you perform your analysis. Then what happens? Do you move on? Will another team that needs this kind of model try to create the model again from scratch? Will they do double work? Probably the industry knows about this, right? And the answer is no. They're not doing double work. They're trying to essentially get models closer to users that want to perform other studies except performance analysis, like the studies we said before. So that is what makes the XiL personas a little bit different than the users that we are serving daily with our simulation libraries. And we come across people, engineers that work in methods team, that they are trying to involve models in more integrated testing. They are trying to hook up all the IOs between the different simulation tools, and we try to explain to them how our APIs work, what protocols we support. And the problems that they face, they are tricky, right? Because the model might fail because it is a setting that the simulation engineer needs to fix, or they might fail because the connections are wrong, or something wrong happens with our protocols and how we implement them. So this is very tricky. But there are also people in the methods team. They have a lot of patience and they are trying to do their work and they're trying to create this whole system models. So that is one key persona that we are trying to serve. Another key persona that we are trying to serve, they are people that running parametric analysis on whole systems for different reasons. We don't have to focus for what is the reason why they are doing parametric analysis. I think it's self-evident, right? They are trying to optimize the system. They are trying to get a certification or something like that. But these users, they just want to do their studies. They just want to, create a report, see if the system at the end of the day will pass the certification, will get the license to be on the road, and it will not produce a lot of emissions, for example. So these users, they don't care about GT. They don't care about any CAE tool. They just want to run their simulations and create a report at the end of the day. And there are a lot of engineers that they are doing this in big OEMs. And that is very tricky to support them also because, when something is wrong with their simulation, then they have to decide, is the model giving me wrong result, or do we really have to optimize the system again? And that is a big chunk of our usage at the moment, which is very difficult to support because we don't have direct interactions with them. That's please, Harshad.
Yeah, just to add on to that, or rather to summarize what Pantelis said, we look for different personas, or rather we work with different personas. Some people who, let's say our job is to deal with people who are physics agnostic people. I mean, they have to deal with a complete system level or vehicle level model. They don't really care about smaller details in a specific battery model or a thermal model or a engine model or a vehicle model. So they look everything as a system. And it's our job to make them feel confident that the model that they are using is accurate enough, is fast enough for their purposes, so that they don't have to worry about the granular details. So that's why we have to. And also on the other side, we deal with people who develop these models in first place. So they are very, let's say, they are the experts in their domain, and they know the each and every detail of the model development or the physics that they are involved with. So in short, we deal with both ends of the spectrum, and it's our job to make sure that all of them are satisfied.
Okay. Yeah, it looks like XiL is a broad field catering to a lot of or a wide range of users, and you nicely summarize different personas using this feature. So I'm curious to know about what is driving the demand for virtual calibration and these XiL simulations. Recently, it has been gaining a lot of traction, and Pantelis previously touched upon it briefly about the faster development cycle. So can you elaborate more on the driving factors for XiL simulations?
Sure, maybe I can start with starting 2 points. Um, in short, the first driving factor is, of course, money. Uh, like what Pantelis mentioned earlier, if you are going to do perform all these tests on the real parts, real components, real vehicle, it of course costs you more time wise, product like product development wise. So everybody is trying to move towards the simulation side to validate their work as much as possible with simulation. Of course, it never will be 100% accurate or uh, 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 to that extent, the accuracy to that extent. So that's one of the driving factor. I mean, again, like I said, it's our job to make sure it is as accurate as possible. So yeah, money is the prime factor there. Second is the development cycle. Nowadays in world, everybody wants new vehicles every year. Well, some tech companies who develop phones has got us into this world where people need new thing every year, but it's not the same for the in this automotive world. But of course, they try to achieve that. They try to reduce their lead time in developing these products. And one of the ways to achieve it is again simulation, simulation, simulation. It costs less, it is faster, they don't have much lead time. The only time it takes is to develop the model, build the model. um, yeah, those are the primary factors which is driving this. Pantelis, you want to add?
Just to add something that you didn't touch upon, it's another factor that one might want to do virtual calibration or perform virtual integration of different models and all of that is essentially to innovate. At the end of the day, they're trying to create new products, the big OEMs, and they want to find innovative solutions. And unless you do system level analysis and system integration with essentially using XiL features from all the vendors, including Gamma, then you're not going to succeed. And just to leave with a small comment here, in one of our conferences, in the US conference, there was one US OEM that essentially explained that their goal for virtual testing and virtual integration and all the digital twin work that they are doing is to reach a point where they can even sell their first prototype after the simulation work is done. So the simulation will essentially, I'm not sure if it is at that level, but that's their goal. That's the goal of the big OEMs to use simulation and not to spend resources on the physical world. And the end goal is to sell even the first product that comes out of the factory based on the simulation.
That would be a dream, right? Like that would cut down so much testing, and also the point that Harshad mentioned before. That's a lot of money to savings to if they can achieve that level of fidelity that they can get a prototype out right after simulation. So yeah, moving on, I know that you guys are very experienced here at GT, and what makes GT very special in our XiL offerings? Could you talk about the different applications? You touched a little bit about the virtual calibration, but there could be applications in digital twins and predictive maintenance that could again save money and rely more on simulations too. So could you touch on that? What's special about GTC offerings?
Yeah, I can take that. So essentially at ZT, we are doomed, let's say, from our founders to be first in class when it comes to physics and results, right? So that is our motto. We are trying to develop simulation software that is the most accurate in the world based on real physics, solving hard, tough equations, PDEs, ODEs, and in a fast way, and also giving the user the freedom to develop its own model, whatever he wants to simulate. We have a modular way to do it. So that is the biggest benefit that we have when we are putting this philosophy and this principle that we have, and I said before, in the perspective of XiL, because we have this powerful tool, this powerful solver that can produce accurate results and trustworthy, proven more than 20 years, right? And when you attach to it modern protocols for co-simulation between models, between even ECU code, between other physical components, then we essentially become invincible, right? Because we have the great combination there.
You touched upon the FMI earlier. Maybe you could elaborate on the FMI because that would be also to be let users interface with other software like Simulink and others that are popularly used for controls. So is that part of GT's offerings? And could you expand on FMIs too, you mentioned earlier?
Yeah, maybe I can continue with that. So like what Pantelis mentioned, our tool GT originally was developed for 1D simulation, which is a strong physics-based tool, very accurate, again proven for so many years. When we started developing into this XiL domain, that's when the need for speed, let's say, came into picture. So we not only want the models to be accurate enough, but also fast enough to deal with these controls uh, models, or move from the right side of the V cycle, development cycle. So to achieve all of these, GT also has these multiple interfaces that you mentioned, Divya. We have a direct API with Simulink because we know Simulink is the lead tool in this industry, what all the OEMs use for developing controls algorithm. Apart from that, again, what Pantelis mentioned, our tool is modular. You can develop system level models, and then if you want to interact them with other system level models, which may or may not have been developed using the GT tool. In such cases, we use this FMI, which is a functional mockup interface, which is an API, I believe was developed by Daimola, if I'm not wrong, some years back, and then other OEMs pitched into it. They helped this API to mature, which is basically it's a standard API across all tools. All tools must follow this API if they want to co-simulate between each other. So this is a standard interface in the industry. And since the beginning now, I think last year they introduced FMI 3.0. We are already in the third iteration of this FMI interface. And of course, GT is GT supports it, and we have all the different supported all the different flavors of this FMI since day one. So, and
Yeah,
yeah,
we hopped on very early on FMI. That was back in 2014, 2013. That was actually my internship testing FMI. Essentially, FMI is a project led by Bosch and, as Harshad said, Modelica, creators of, I think, Daimola, and it is led by these companies, and it is uh, the motivation essentially came from OEMs, because OEMs have all these different simulation teams, and they noticed that the different tools that they are using don't talk to each other, because maybe they are competitors, maybe they don't know each other, and it will be who knows how long to essentially for all the tools to speak with each other, all the software vendors speak with each other, so that at the end of the day, to let the OEMs do what we said before, sell their first prototype, right? So that's why they came up with the FMI standard. It is it is going to standardize the way it is not going, but it has standardized the way software, CAE software and other software um, speak with each other. It is very simple. It's based on XML and C code, and more than 100 tools supported. So it is filled with many possibilities, and it's also made Harshad and I and myself and my life easier, because we don't have to maintain 110 or whatever the number will be links. We only need to support one. And of course, a link with Simulink, a link with Python, link with C code, with metamodels, with all these different areas. This is something that we support. The only thing that we don't support and we cannot claim we do it is with regards to CFD. CFD coupling is handled by a different group here at Gamma. And it makes sense because it is very complicated to do.
All right, guys, that's a lot of technical details. If you want to switch gears a little bit, with all these technical capabilities, what are some applications that we're looking at, and what do our customers and industries want out of these simulations too? Could you talk about that?
Yeah, sure. Since we touched upon this a bit earlier, you spoke about virtual calibration, some digital twin. These are the new things that we have been hearing in the industry. People want to do, of course, they want to do virtual calibration. They don't want to spend more time and money to do it in the real vehicle or on the dyno cells, or bring your software calibration to a level where you don't blow up your engine, right? So you calibrate your controls to 70-80% virtually using the tools, and then you take it to dyno for fine tuning, something on those lines. And yeah, we have been hearing those requests for quite some time, and we developed this new feature which we call XCP harness. So XCP is a protocol which basically where you can talk directly to the ECU, where you can calibrate the values for the controls algorithm within the ECU. You can send back those and actuate the different components. So we have developed this XCP harness and where you can talk directly to this ECU using just the GT model. So we are working with one of the OEMs right now who have already successfully tested this, validated it, and they are taking it to a next level. So to touch in short of what they did, they had the engine model developed in the GT domain. They took that engine model in their laptop to a dyno cell. They hooked up their XCP protocol. So Inca is the tool which is primarily used to read all these ECU signals, send signals across, and this XCP protocol connects directly to Inca. So
It's
that's
really
a
cool.
very cool feature that, and they want to expand this into other domains. They want to take this now a virtual engine, which is a highly calibrated engine, and put it in a chassis dyno. They actually tested this in a real car. They drove the car on the track, and they had a GT engine model in a laptop in the car, and they were matching results. And in fact, our CEO and CTO, they happened to enjoy this. They were in the car while this was happening.
Thank God.
And
Thank God the CTO didn't drive, right?
well, yeah, that's true. That is true.
It's encouraging to see that the results were on top of each other. And I believe this enables something called driver in the loop. So can you elaborate, uh, or if I'm not wrong, this is driver in the loop. So can you explain a little bit more about that?
Yeah, it can expand to driver in the loop applications, right? So we talked about hardware in the loop, and then there is the driver in the loop, which is later on or close to hardware in the loop. And essentially, what's happening in these applications, you have these platforms that they are essentially including the full cockpit with all the dashboard, the seat, the gears, the wheel, and everything. There are companies that provide this kind of equipment, like VI Grade and other companies. And essentially, what they're trying to do is they are trying to replace or substitute the need for having a big track and run tests on the track with either race cars with or without CEOs and CTOs in the back seat and all this and all this exciting stuff. So that's what happened a few years ago with Maserati, right? So they have this innovation lab in Modena, and they have a couple of simulators there, driver in the loop simulators, and the team there is pretty bright. There are pretty bright engineers there. They're using a GT since many years, and they see the opportunity. They want a more accurate driver experience because essentially who gets to go in the seat is actually the driver, the race driver, or the company driver who drives the cars on the track and decides if what is the harness, the noise, and everything there, and at the same time, what are the different key metrics like performance, emissions, and stuff like that, depending on the driving style. So that is the need for the driver in the loop. And at Maserati, they innovated a lot there. They had a couple of simulators, which essentially we took the opportunity to break one of them, right? Because they are using our tools, and one model had a specific bug that we have to go live and fix. And that was one of my career highlights here at CT that I've been bugging Harshad and the team about a lot. It's like what we said before, right? You do a marathon and then you never stop talking about it. So we went there with PowerTech engineer at that point, and we fixed the simulator. And just because we had booked a couple of hours the simulator, we fixed it in the first 30 minutes. It was a quick fix, honestly. And the rest 1.5 hours we were taking shifts and we were driving the simulator. So I can say that it was a great experience.
Yeah.
And
You didn't invite me, right?
no, I couldn't. Like I was the one essentially introducing the bug, right? So that they can call me in.
Yeah,
Sure.
I
Yeah.
see the strategy there.
You know what?
Exactly.
Now I'm going to build my own simulator here in Westmont, and let's see
Uh-huh.
how it goes.
Exactly. Exciting. I'll probably have more reasons to come visit Westman office.
Yeah.
So
Nah,
yeah,
I'm not
that
inviting you.
that is the driver in the loop application, Lalit. Essentially, trying to substitute big, big racetracks with just a room with just a room with a platform and a 200 degrees, a 180 degrees screen with the real driving feeling with the steering wheel and everything. And of course, Gamma in those applications provides the models because the graphics and all the actuators and stuff, they're not coming from Gamma. But if you don't have an accurate engine if you don't have an accurate AC model that can reduce the torque depending on what is the driving style and all of that, then you cannot have a real feeling. So that's how we complement those applications.
And
So
Pantelis, I
somewhat like
believe you already have a paper about it, right? So
Yeah, we
Oh
can
yeah,
link
maybe
the paper in the
yeah,
description for our
yeah.
listeners, viewers.
paper is not important. I've driven the sim.
he
Of
went
course,
for the
yes.
simulator. I think paper was a byproduct of everything.
Well,
Yeah,
people like me can enjoy just by reading the paper, I guess.
be my guest.
Yeah, yeah.
So we can talk about what other advanced simulations or applications you are exploring, and what's the future of this XIL simulations in terms of the features and the industry adoption.
Who
We can talk
wants?
about maybe meta models, maybe to some extent. So the idea here is now we have proven that the physics-based GT model is really useful across the entire V cycle, and many OEMs have been using us for years. So the next step that they want to take is, can they use GT or GT-based planned models in a virtual ECU, in an ECU? So the short answer to that is not no, no, not directly. And that's the advanced work that GT has been doing recently, that now we can extract the meta models out of the physics-based GT models. And these meta models now can be used in the ECUs or can be embedded into ECUs. And that's something that we are exploring right now. We are trying to get more people to use it or help us develop that feature more now. Maybe Pantelis,
Yeah,
want to add something?
we're doubling down in that application, and we're also doing a lot of work on the XCP harness that we said earlier, because we see great potential for calibration engineers to use predictive models coming from GT and directly speak with their code, directly co-simulate with their code. And we think that this application is going to also expand a lot the user base, because the way it works is that you have to install an OpenGT for it in some cases.
We are trying to create a digital twin of the real world here. So let's see how it goes.
Yeah, because there are lots of opportunities for these applications in wide range of industries. So it's excited. I'm excited to see where we go with these applications. All right, thank you, Pantelis and Harshad, for joining us and sharing all the insights and your experiences and the marathon. We appreciate your time, and thank you to our listeners for tuning in, and we'll see you next time with other interesting topics. Thank you.
Thank you.
Thank you, guys. Thank you for inviting us.